Hello student, welcome to VidyaNest. See, we are going through binomial theorem. This is class number 3. Let us recall in short span what we are
Okay.
taught in last day at the last phase. Okay? See, we got suppose there is one term there is a binomial expansion like this. We have to find the number of integral terms, finding number of integral terms in the expansion. Okay, last day we had left the topic with the concept of this. Okay, you can hear me, I think.
Yes, sir, I can hear you.
Now, if n is completely divisible by either P or Q, then number of integral terms is n by LCM of P by P and Q. This is, it symbolizes the integral part plus 1. This is number of integral terms. We got this concept last day. Today we are just recalling that, content.
Okay,
Okay?
sir. Yes, sir.
So this is the expansion. We have to find the number of integral terms in expansion. Now if n is completely divisible by either P or Q, then number of integral terms is this.
Yes.
This thing implies the integral part, greatest integer function. And if n is not exactly divisible by either P or Q, then n by LCM of P by Q. Few examples we did last day. Let us do,
Yes, sir.
let us do few more. Just 1 minute.
Okay.
See, the number of of e to the power half plus 5 to the power 1 by 8 whole to the power n option A, option B, option C 256. See, it came in repeated manner, means in 2-3 years it came. It came in 2013, 2020 and 21. JEE 2013, 2020 and 2021.
Okay, sir.
Now let us reshuffle our knowledge to solve this. Here, if you get one expansion of this form, see, you have got it in this form. A to the power 1 by p, b to the power 1 by q to the power n. Find number of integral terms. See, one criteria I missed out, where a and b are prime numbers. A, b are prime numbers. So all the categories are satisfied. all जो कैटेगरी जो है ये ए एंड बी प्राइम नंबर, यहाँ पे देखो, यहाँ पे 3 and 5 वो प्राइम नंबर होगा, ठीक है. एंड सी integral terms is exactly 33, means this thing, this plus 1 will be 33. So I will consider that n will be divisible either by 2 or by 8. Okay. Okay. So let us proceed with the formula. Those who do not know this formula hardly can solve this in exam. But if you know this shortcut trick, within 2 minutes you can defend this sum. Let's see how. See, number of integral solution, integral terms, sorry, n by LCM of 2 and 8, because 3 and 5 are already considered prime number. So LCM of 2 and 8 with its integer value plus 1. Okay?
Okay, sir. Yes, sir.
Yes. Now, you see that is equal to 33 given. Box of n by LCM of 2 and 8 is 8. LCM of 2 and 8 is 8. Okay.
Yes, sir.
So box of n by 8 is equal to 1 will go in the right hand side, it will be 32. Now if any integer, if you get any integer like this, so where does x lies? X, what that is the criteria box function. If box x is equal
Yes,
to
sir.
n, x lies between n and n plus 1. So if box of this thing is equal to 32, so n by 8 lies between n by 8 lies between 32 and its 33. इस उसका जो नेक्स्ट वैल्यू है इसका बीच में रहेगा, ठीक है.
Oh, okay,
Now
sir.
if n by 8 lies between these two, where does n lies? Cross multiply. So if I take that inequality, so it represents what? N is greater than 256 or equal to 256, and we are asked to find least value. Least value means n cannot be lesser than 256. 256 onwards, understand? So
Yes.
okay, so least value of n 256. Does it match with any option? Yes, it match with option C. Okay.
Okay, sir.
So this is one type which students had to face frequently. So if you know the shortcut trick, so the sum becomes so simpler for you. Now, next type. Suppose if you get one expansion like this, 1 plus x whole to the power n. How will you expand it? nc0 plus nc1 1 to the power n minus 1 into x plus nc2 1 to the power n minus 2 into x square plus nc3 1 to the power n minus 3 into x cube up to ncn 1 to the power n minus n into x to the power n. So that is a general expansion of 1 plus x whole to the power n. Now you can represent it in other way according to your will. See, you can keep n silent and see 1 to the power whatever, that will remain 1. So this expansion can be written in revised manner. C0, C1x, C2x square, C3 x cube, Cn x to the power n. So 1 plus x whole to the power n can be written as this expansion. N is not written. That means we'll pretend that n is silent. Seeing this power, assume होगा कि ये nc0 nc1 ये सब है, ठीक है? Understood? Now if I put x is equal to 1, what I will get? You got the idea before. I will get 1 plus 1 whole to the power n, and in each case, in each of these x, if I put 1, I will get sum of the coefficient of the expansion. Okay?
Okay, sir.
So that is 2 to the power n. 2 to the power n. Now, if I put x is equal to minus 1, that will give us same thing? नहीं, एकदम नहीं. Put minus 1. 1 in place of x minus 1. So C0 in place of x minus 1 minus C1 plus C2, C3 up to Cn minus 1 to the power n. So this 1 minus 1 will give you 0. C0, C1, C2, C3 up to Cn. Now leaven it by equation 1 and leaven it by equation 2. Now if I add these two, if I add 1 and 2, if I add 1 and 2, we get 2 to the power n plus 0. See, if I add this and this, see that odd coefficient will get cancelled. हाँ, cancel हो जाएगा.
Yeah.
और जो even coefficient है, ये each even coefficient will repeat twice. C0, C2, C4 and so on. So sum of the even coefficient is 2 to the power n minus 1, because if I drag this 2 in the below of 2 to the power n, so by laws of exponent I can get 2 to the power n minus 1. That is sum of even coefficients. So by adding I got that. So by subtracting I would
Yes.
have got what? अगर तुम ऐड किया तो इवन कोएफिशिएंट रह गया. अगर सब्ट्रैक्ट करोगे क्या होगा? इवन कोएफिशिएंट कैंसिल होगा, ऑड कोएफिशिएंट रहेगा. ठीक है?
Yes, sir.
अगर कोई जगह में दिक्कत है तो बोलोगे. हाँ, क्लियरली.
Okay, sir.
By 1 minus 2 we would have got, see, 2 to the power n, वो तो 2 to the power n ही रहेगा. यहाँ पे भी जब सब्ट्रैक्शन का बात है, जब ये देखो C0 कैंसिल हो जाएगा, C2 कैंसिल हो जाएगा. जब C1 माइनस ऑफ माइनस C1 ट्वाइस C3, ये जो ईच ऑड कोएफिशिएंट ट्वाइस will come. So C1, C3, C5. So 2 to the power n minus 1, sum of the odd coefficient. Okay? So this is the way in
Oh,
an expansion like this, you will get sum of the even or sum of the odd coefficient. Okay.
Okay, sir.
Now, in binomial, sometimes we will have the requirement of differentiation and integration. How? Let's see. Suppose one expansion is given 1 plus x whole to the power n, c0, c1x, c2x square up to cn x to the power n. Then you are told to find c1, 2c2, 3c3 up to ncn. You are told to find this, and this sum can be done in two ways, both the way I am showing. First, you know, I will show with pure binomial method, because those who are orthodox mathematician cannot accept the use of calculus in binomial. Okay, but see,
Okay, sir.
there is a change. We need shortcut trick. But see, first I will show you how to do it by normal binomial method. First of all, here you see power of this exponent of this binomial is n, but here n is silent. So this C1 means actually NC1 plus twice NC2 plus thrice NC3. In this way, NCN. Now NC1 means what? With formula you go n minus 1 factorial into factorial 1 factorial n minus 2 factorial into factorial 2 plus thrice factorial n minus 3 factorial into factorial 3. The show will go on up to the last term, n factorial n factorial n minus n factorial factorial n. So this is the simplification using the formula of NCR. Now if I cut the numerator by denominator, I will get what? N, because factorial n is n into n minus 1 factorial. 2 n minus 1 n minus 2 factorial, it will get cancelled, plus 3 n minus 1 n minus 2 n minus 3 फैक्टोरियल जब मिलेगा वो डिनोमिनेटर का n minus 3 फैक्टोरियल से कैंसिल हो जाएगा. इन दिस वे n इंटू c1, यहाँ पे फैक्टोरियल n फैक्टोरियल कैंसिल, 1 by factorial 0. Now in open I, what can I take common from the whole expansion? What is only one common factor we can get? N up to n. Okay, so
Yes, sir.
वो n तो हम कॉमन ले लिया, बचेगा क्या? अगेंस्ट दिस n 1, ये 2, एक 2 भी कैंसिल हो जाएगा, फैक्टोरियल 2 मीन्स 2, n minus 1. Now 3 and factorial 3 can be cancelled by, देखो ये 3 होगा, 3 into factorial 2, 3 क्या कट जाएगा, factorial 2 बचेगा. और what one n is already taken common. लास्ट टर्म भी 1 हो गया, because factorial 0 1. Now I forgot to write this thing. If I, to ease the calculation, if you wish, you can write let this n minus 1 is equal to capital N. So if so, I will not encroach anything in this n because that is already kept outside the summation. So no point of disturbing that. So I will get what? 1 n. This is n minus 1 by factorial 2 up to 1. Now you see, let us recall this thing. See, once I had put x is equal to 1, I got sum of the coefficient. हमको sum of the coefficient मिला था, है क्या? है, understood?
Yes.
So ये 1
Yes, sir.
plus 1 whole to the power n. यहाँ पे you see, if you observe carefully, I can write NC0, capital NC0. Capital N means capital NC1, capital NC2 up to capital NCN. So this is also sum of the coefficient. Yes or no?
Yes, sir.
So instead of this, I can write 1 plus 1 whole to the power capital N. Now capital N to substituted value. Now drag that value and put here. N 1 plus 1 is 2, n minus 1. This is the result of that expansion. Now this method, conceptually it is sound, but it encroaches some extra time. So if we implement calculus here, means in this case differentiation, because here you know the power is coming out of the variable. So it is somehow can relate to differentiation. So if I do this sum with differentiation, then it will be much more simpler. So you do one thing, you differentiate both sides with respect to x.
Okay, sir.
The same sum is being done with calculus method, and I hope it will seem to you easy. तुमको ये थोड़ा easy लगेगा. ये जो part है.
Yes, sir. Sir, if this sum comes in the board, if we do by the calculus,
No matter.
will I get
These days, teacher will not cut marks because see, all of us are accustomed with that. But if we don't know the conventional method, then it will be injustice to the subject. Yes or no? Subject की तो जो हम respect है subject का towards subject, वो ठीक नहीं होगा. Okay? है कि नहीं?
Yes, sir.
तो इसीलिए now come to the tricky method. TDX C0, C1x, C2x square up to Cn x to the power n. So here we will use chain rule. D 1 plus x to the power n variable. See here, variable is a base is variable, but variable is generated by 1 plus x. So once the base variable is 1 plus x, so with respect to 1 plus x, we will differentiate. But we had x, so to balance, you differentiate 1 plus x with respect to x. This part actually, this differential operator balance the differentiation. Now, is it a constant term? Is differentiation 0? C1x,
Yes.
x का differentiation होगा 1, C2 x square, C2 तो constant बाहर आएगा, x square का constant 2x differentiation C2 in this way 2x C2 last term, okay, C Cn n x to the power n minus 1. So this part will remind you the formula 1 plus x to the power n minus 1. 1 का डिफरेंशिएशन 0, x का डिफरेंशिएशन 1 होगा. और
Okay, sir.
ये जो इन एक्सपेंशन पार्ट ऐसे ही रहेगा. Now, how to remove this x? x के जगह में कोई क्या पुट करना होगा? 1. Now you put x is equal to 1. n 1 plus 1 to the power n minus 1. So, see, much more simpler approach, yes or no?
Yes, sir.
The same thing we have got, but with simpler approach. In the same manner, just wait. Suppose Cn x to the power n, you are told to find C0, C1 by 2, C2 by 3, C3 by 4 up to Cn by n plus 1. See how to comprehend. Now what property of calculus to be used here? Okay, what how?
Okay.
Okay, see in the previous sum that 2, 3, 4 were coming as the coefficient of C0, as the what I can say, association of C0, C1, C2 up to Cn. Now they are coming in the denominator. Once you get the terms in denominator, that will remind you the integration. I think basic level integration, x to the power n plus 1 by n plus 1, mainly in physics the student of class 11 are already taught. ठीक है?
Yes, sir.
देखो x to the power n, नीचे एक n plus 1 term आ गया. So here the terms visible in the denominator actually reminds us the application of that formula of integration. So we will integrate both sides with respect to x. See, integration of the whole thing. See, here 1 plus x is the variable of the base and here x. So you can directly we can write, see one thing, suppose if you are differentiating dx plus 1 with respect to x, you will get 1. So differentiation of dx plus differential of x plus 1 is same as dx, because if I cross multiply, I will get dx plus 1 is equal to dx. So once
Yes.
we have seen that the uh, variable of the base is 1 plus x, but we are told to integrate with respect to x. So our motto or our aim will be to make the variable same. And once we have come to know that dx plus 1 is equal to dx, so इसके जगह में हम क्या पुट करूंगा, dx plus 1. Like differentiation, that integrand or the integrable function will be splitted into n number of integral, like differentiation.
Okay, sir.
Okay.
Yes.
So here see, तुम डिफरेंशिएट कर रहे हो किसका रेस्पेक्ट में, x प्लस 1 का रेस्पेक्ट में, और जो इंटीग्रैंड और फंक्शन मिला वो भी x प्लस 1 का रेस्पेक्ट में. तो डायरेक्टली आई कैन यूज दैट फॉर्मूला. C0 कांस्टेंट बाहर आ जाएगा, मिलेगा क्या 1. C1 बाहर आ जाएगा, रहेगा क्या x. C2 x square dx and Cn C0x C1 plus k. What is k? K is integration constant.
Oh,
Integration constant. Now our role is to find that k first. So we have k with this algebraical expression generated by x. So if I can drop the whole expression, अगर ये ऑफ कर सकता है, if I am able to off this, drop this, तो k निकल जाएगा. तो सब सब
yes.
सब कोएफिशिएंट के साथ x है. तो अगर हम x के जगह में 0 पुट कर दूं, if I put 0 in lieu of x, I will get what? 0 plus 1. ये पूरा 0 हो जाएगा, C0 into 0, C1 by 0, पूरा 0, k बचेगा. So k
Okay, sir.
1 by n plus 1. तो k का वैल्यू निकल गया. Now that
Yes.
value will be dragged and put here. C0x C1 x square by 2, C2 x cube by 3, Cn, what is k? Few minutes back ये मिल गया था.
Uh, yes.
Okay.
1 by n.
Yes. Now I will, ये जो पार्ट है ये साइड में लेके आऊं.
Okay, sir.
So now you look at the figure which you are told to prove. See, you are told to prove, or you are told to find this figure. See, there is no x. There is no x. And you observe what you have got. You have got with all coefficient which you are told to find, but with x. है कि नहीं?
Yes, sir.
So if I can remove this x, I can get the exact expression. So remove means if I put 0, तो पूरा 0 हो जाएगा. तो 1 put करो. In place of x, 1. So it will become what? 1 plus 1, 2. C0, C1 by 2, C2 by 3, Cn by n plus 1. So we have got the result of that expansion. Okay.
Okay, sir.